I thought we will start with that, but not yet. So we have limit as x approaches 0 from the right from 1 plus sine 3x cotangent x. When we plug in 0, we get 1 in parentheses, and cotangent is cosine over sine. Sine is 0, so this is 1 to infinity. Would you agree with that? So, of course, this is the most difficult or uncomfortable, if you want, or cumbersome, if you want, case of indeterminate case. So I'll write y equals 1 plus sine 3x raised to cotangent x. Agreed? Then we apply natural log. So we get cotangent x times natural log of 1 plus sine 3x. Next step, agreed? Okay, so then I apply limit of natural log y as x approaches 0 from the right. Now, if you remember, we said as long as you are determining the limit, you cannot drop the limit operator. Some of you wrote equals and equals and equals and equals and equals without the limit operator, which is incorrect. Please do not drop the limit operator till you apply the limit. Okay, then we had limit as x approaches 0 from the right from natural log of 1 plus sine 3x over tangent x. Because tangent is 1 over cotangent, when you flip that, you get cotangent at the top. And now this is 0 over 0. And then you will differentiate. 1 over 1 plus sine 3x times cosine 3x and times 3 over secant squared x. And now when we apply 0, this is 0, this is 1, this is 1. So the answer is 3.
Well, I got 3 somehow, but...
Now we copy the beginning and we copy the end. So then limit of natural log y as x approaches 0 from the right is 3. This is the moment in which we say by continuity, only by continuity, of y and natural log y, these are continuous, we are allowed to swap the operator. Which operator is natural log with limit? So we have natural log then. Natural log of limit as x approaches 0 from the right of y equals 3. And now the question is what this could be. And there is only one answer. What can it be?
Cancel out that line, we could raise it to e to make it e to...
Yes, that's another way of doing it. Yes, you're changing it to an exponential equation. Correct. The base raised to 3 equals that. That's a very good way. So then limit as x approaches 0 from the right from 1 plus sine 3x raised to cotangent x is indeed e to the third.
Is there any way to, like, let's say we, like, I forgot that, like, cotangent is 1 over tangent x. Is there any other way to do it if we forgot that step where you have to know?
You're making more the problem more difficult because then cotangent inverse is you're never gonna finish with it. It will always have 0 in the denominator. Okay. Any questions? It's okay as long as moving forward you remember these steps, because you're going to have a problem like this on the next test, and you're going to have a problem like this on the final, right? So please make a note of it, okay? It's okay. I was hoping, but I understand why you were probably not super ready for this. Okay, 4.9. Any questions for me? So the material for test 3, which will be 2 weeks from today, is completely done. No more new material for this test. That's done. What we cover now, which is 4.9 and 5.1, will be on test 4. Okay? 4.9, antiderivatives. First of all, notation. Given f prime, find f. Given f, find uppercase f of x. So of course these are all of x. And you can say, what's the big deal here? When we get to chapter 5, you will understand. So one more time, what is all this? Basically, moving forward in 4.9 and chapter 5, we want to go backwards. What does that mean? It means we are given the derivative and we want to find the function. In other words, I have the velocity function. I want to determine the distance function. Or I have the acceleration function. I go backwards to find the velocity function, even further to determine the distance function. If I am given the first derivative, the notation for the function that I have to determine is f of x. But the derivative is just a simple function. So I could be told, here, this is a function. Who cares what it is? It may be the fifth derivative. I don't care. It's a function. Find its antiderivative. I have to use the notation uppercase f. So let's look at an example, and then we'll look at some technique. But a simple example with, let's start with, let's say, acceleration. So page 349, I would like to choose from 59 to 64. So any problem that gives us the acceleration, it says the particle is moving with the given data, find the position of the particle. So let's say we're given the acceleration, we need to go back and find velocity, bless you, Justin, and then we have to go back and find the formula for the movement of the particle, or we also call it the displacement, or the position. 61. 61 it is. Where was it? Okay, so we want 61. Okay. I don't have enough information for 61 just yet because I didn't show you any specific technique yet. I'd like to use either 62 or 63. And then we'll go back and do 61, I promise. But I haven't showed you the technique yet. 62 or 63. Never mind, 62. Okay. Okay. So in 62, on page 349, we are given a of t, which is 3 cosine t minus 2 sine t, and s of 0 is 0, and v of 0 is 4. Disregard the given conditions for a moment. So the question is asking us to find s of t. This is what we are asked to find. The formula for the position of the particle, if you want, or the distance formula, or the displacement formula. They're all mean the same thing. So, in other words, this is the derivative of a function. Which function? Well, is the derivative of v of t. So somehow we have to find our way backwards. So we have to determine a quantity or a function whose derivative is 3 cosine t. Can we find a function whose derivative is 3 cosine t? Negative 3 sine t. Positive 3 sine t. You're very powerful today. So when we differentiate 3 sine t, do we get 3 cosine t? Good. Now we want the same thing, another piece, another function that we differentiate to get negative 2 sine t. Yes, plus 2 cosine t plus a constant c. Let's stop for a moment and make sure that this is correct. if I differentiate b, do I get a? 3 sine t prime is 3 cosine t. Positive 2 cosine t prime is negative 2 sine t. When I differentiate the constant, I get 0. Would you agree? Very good. So I am given a piece of information that b of 0 is 4. What does that do? Why do I need that?
To solve for C.
To solve for c. Very good. So the left-hand side is 4, and then I plug in 0 everywhere to find c. So the left-hand side, 4, 3 times sine 0 plus 2 cosine 0 plus c. But how much is sine 0? Perfect. How much is cosine 0? Yes, with 1 times 2, yes. So 4 equals 2 plus c, so then c must equal 2. So now we determined the unique velocity, 3 sine t plus 2 cosine t plus 2. This is the unique function. There is no other function that fits the given information. So we are one step closer to finding the distance formula, correct? So S of t we want to determine the function whose derivative is 3 sine t. And now I agree with negative 3 cosine t. Is that true? Yes. When we differentiate negative 3 cosine t, we get 3 sine t. Agreed? Good. So now we need the second piece. When we differentiate this, we get 2 cosine t. So plus 2 sine t. Now careful. Plus 2t plus, since I used c already, this time I'm going to use d just because, or sometimes I would use c1 and c2. It doesn't matter really. Do we understand? Let's do this one more time. Negative 3 cosine t prime is that, correct? 2 sine t prime is that, correct? 2t prime is that, correct? And then d prime is? Perfect. We have one more piece of information. S of 0 is 0, which will help us find d. So 0 equals negative 3 cosine 0 plus 2 sine 0 plus 2 times 0 plus d. What does that mean? How much is 2 sine 0? How much is 2 times 0? Good. So this is negative 3. So 0 equals negative 3 plus d. Therefore, d equals? Very good. Excellent. So then S of t was fully determined as negative 3 cosine t plus 2 sine t plus 2d and plus 3. There is no other function that fulfills the given information. Okay, before we move on to other problems, I would like us to look at the power rule. We said in the past that when we differentiate x to the third, we get, very good. But what if I have here, and when we differentiate x to the nth power, we get to n minus 1. Very good. But now, I want to find the function whose derivative is x to the n. So which function I differentiate to get this?
X to the n plus 1 over n.
Indeed. So if I want to get here x to the third, what will I get here? Which function do I differentiate to get x to the third? X to the over? Yep. That's the formula. So then, now we're ready to solve any problem you want. So choose anything from 29 through 48. Let's start with 8. Yes, which one? I thought you would pick one. So since we looked at sine and cosine, a trig function, let's look at something else. Maybe, I don't know, maybe this one. Polynomial function degree 2, quadratic. Is that okay for now? Okay, let's look at 39. Page 349. We are given the second derivative, like we just did, plus 12x minus 12x squared. And we are told that f of 0 is 4, and we are told that f prime of 0 is 12. Of course, the question is, find f. If this were f, lowercase f, then we would have been asked to find the uppercase f. Okay, ready? We have to find the first derivative first. Which function prime is negative 2? The answer is negative 2x plus 12. We increase the power and we divide by 1 and we divide by the result. We increase the power and we divide by the result. Or C or C1. So we're using now the power rule for antiderivatives. So negative 2x is prime is negative 2. Here, when you bring down the power, you will simplify the power and you get a 12x. Here, when you bring down the power, you simplify the power and get negative 12x squared. And when you differentiate C1, you get 0. Is this okay? We will simplify it as much as we can. So f prime of x equals negative 2x plus 6x squared minus 4x cubed plus C1. And we are given a piece of information. They are telling us that f prime of 0 is 12. That will enable us to find C1. So please plug in 0 all the way and give us C1. How much is C1? Of course, thank you very much, Eric. So this is f prime. I'm going to rearrange it in descending order. Negative 4x cubed plus 6x squared minus 2x and plus 12. This is good, but it's not good enough. We have not determined the function yet. So now f of x. Can anyone dictate?
Negative x to the 4.
Yes, let's write like this for everyone to see. You're right. You're way ahead of me. That's fine. And nothing wrong with that. It's perfect. Negative 2x squared over 2 plus 12x plus C2. So we copy negative 4. We increase the power of x and we divide by that power. We copy 6. We increase the power of x. We get 3. We divide by that number. We copy negative 2. We increase the power by 1. And we divide by the result. Plus 12x plus C2. Is everyone okay with this? Everyone? And yes, we have to simplify. And f of x is negative x to the 4th plus 2x cubed minus x squared plus 12x plus C2. And now we are also told that f of 0 is 4. So therefore, the only function that fits the given information is f of x, negative x to the 4th, plus 2x cubed, minus x squared, plus 12x, and plus 4. And this is it. There is no other function that fits the given information. Ready for one more before we move on? Any questions? Is this okay? Okay, 46. Slightly different situation. In 46, we have the second derivative of t equals 2e to t plus 3 sine t, and we're told that f of 0 is 0 and f of pi is 0. Any questions on that? Anyone? Any questions, please? Sarah, are you okay? Again, we are given the second derivative. Again, we have the same question here. Find f of x, f of t. The specific f of t that complies with all the given conditions. So we find the first derivative first, going backwards. Can anyone tell us what to write?
2
Very good.
minus 3 plus 9
Plus?
c.
Good. Excellent. I don't have any information about f prime. This is not f prime. So I have to move on to f of t. Can anyone work on this and tell us what to write? 2e to t
Minus 3 sine t plus ct
c1t plus,
c2.
exactly. When we don't have any information about the intermediate function, like in this case, f prime, we're given two pieces of information about f. Why? Because we have two variables, c1 and c2, or two unknowns. So let's look at the first condition. The first condition says f of 0 is 0, so 0 equals 2e to 0 minus 3 sine 0 plus c1 0 plus c2. I shouldn't even write this, but I want you to see it. And of course, these two go away. How much is e to 0? 1. So when I move it to the other side, c2 becomes
2 plus b. 2.
but I have to move it to the other side. Negative 2. Do you all agree with negative 2? Okay, so then f of t is 2e to t minus 3 sine t plus c1t minus 2. We still have a variable in there, but we are also given that f of pi is 0. From the second condition, we are going to determine c1. So again, the left-hand side is 0. 2e to pi minus 3 sine pi plus c1 times pi minus 2. 2e to pi is a number, I can simplify that. But what about sine pi? Sine pi is 0. So then c1 pi equals 2 minus 2e to pi divided by pi. And now we have the function f of t 2e to t minus 3 sine t plus 2 minus 2e to pi over pi times t minus 2. And this is the unique function that complies with the given conditions. What conditions? F of 0 is 0, f of pi is 0, and the given second derivative. Is this okay? Yes? Any questions? Okay. Here's a function for you. F of x, let's say, is 2x to the third minus 4x plus 2. the requirement is find the most general antiderivative of f of x. First of all, what would be the notation? Very good. So this will be uppercase F. It will be 2x to the third, 2x to the fourth over 4 minus 4x squared over 2 plus 2x plus a constant c. The constant, yes, we're gonna clean it up in a minute, but the constant can be anything, any real number. So this is basically a family of functions that all have the same derivative. This is not just one function. Infinitely many functions, a family of functions whose derivative is that, not just one. And that's the most general antiderivative of f of x. So this is x to the fourth over 2 minus 2x squared plus 2x plus c. This is the most general antiderivative of the given function. Any questions? Any questions?
What do we do with that?
We were only asked to find the most general antiderivative. We were not given conditions. The conditions were given for us to determine the specific function. One, just one, that has, let's say, f of 0, 0, f of pi 0, and the given derivative. So we were given all those conditions to find one, specific one that fulfills all the given conditions. This time we're asked to find all possible functions that have the same derivative. And all possible functions are these, where c, let me write this down, c can be any real number. C can be any real number. And this is a family of functions. Family of functions. They all have the same derivative. Okay. Chapter 5. I don't want to put the title up, because by the time we get to the title, it will be a long time, and you will forget the title. So first of all, we are going to talk about the sigma or summation notation. I don't want to talk about that word just yet, because it doesn't mean anything right now. We have to build up to it, and then I'll tell you what it is. Of course, it's integrals, but we don't want to talk about it yet. We have a long way till we get to those. And I don't think it's going to happen today anyway, so. Okay. Before I show what it is, let's suppose we want to add 1 to 2 to 3, ... exactly 3 plus n. This is not the way we write it. We use a notation that represents the sum. So 1 plus, 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 plus. So this is the summation or sigma notation. Well, why can't we use S? Why do we have to use this, which is the Greek letter S? Why do we need a sigma instead of S? Also called summation notation. Only because it has a very convenient form. The bottom of it right here will contain the index. It will contain the index and also the lower limit. It's very convenient when I equals 1. I is the index, 1 is the lower limit of the index. That's where the index starts, with 1. The index can go to up until n. How do I know? From 1 to n. And this is from I. So instead of writing this, we write this. N, of course, is the upper limit. We prefer as index I, J, or K index. Is it okay to use A and B and C? Of course. It doesn't mean anything. So, but you will see it mostly I, J, or K, from I equals 1 through N from I, or from J equals 1 to N from J, or from K. But, so what does this mean again? When I is 1, I have 1. Then the summation notation says plus. When I is 2, I have 2. Well, then plus. When I is 3, I have 3 plus. Dot, dot, dot. When I reaches N, the upper limit, I get plus N. Here's another example, and I would like you to come up with the formula. 1 to the third plus 2 to the third plus dot, dot, dot plus N to the third. Let's, for the sake of the argument, let's use J now. How will you write this sum of terms using the sigma notation? Sum or sigma from? Yes, okay. Till? That's it. That's all it means. Let's look at one more. Ready? 3 plus 4 plus 5 plus dot, dot, dot plus N plus 2. Yes, the sigma, very good. The summation notation from, okay, let's just simply use J equals 1 till N from, yes, plus 2. Let's check. When J is 1, I have 3 plus. When J is 2, I have 4 plus. When J is 3, I have 5 plus. When J is N, I have N plus 2. And we can continue forever. There are so many different examples, right? Okay, properties. There are two properties that we have to mention here. The general term is denoted normally by A sub I, which can be anything. So the notation is basically from I equals 1 to whatever n from A sub I. That's a general term. What if I have a sum of two generic terms or general terms, or the difference? What do you think this will equal to? Just a wild guess. Of course, it's like with the limit, right? Same idea. So this is a sum of AI plus or minus the sum of BI. Of course, from I equals 1 through n, from I equals 1 through n, where AI can be anything. So this is the first property. And then you'll figure out the second one very easily. So let's say I have a sum from a constant times AI from I equals 1 through n. What do you think this equals to? Exactly like with the derivative, exactly like with the limit. What do you think I'm going to do with that constant? Exactly. Common sense. These are the two properties that we need moving forward. And now you can say, fine, this is all beautiful. What's the application of this? That's my next step, to show you where I need this and where we need this. Okay. So we know what sigma notation means and how we elegantly we can write a sum of whatever number of terms using this notation and what it means and those two properties. Here's our next adventure. Find the approximate area under f of x equals x squared, the graph of f of x equals x squared on 0, 2. And you can see why, and I'll explain later why. And who cares? I'll explain why later. Who cares about this? And how we determine it is this. Okay, so let's graph. 1, 2, 3, 4, 1, 2. Here's 1 point, here's another, here's another. So this is the graph of x squared between 0 and 2. And I have to add one thing here. Find the approximate area under this graph on the interval 0, 2 using 4 subintervals. And if you say, why 4 and not 15 or 20, we're getting there. Let's start with 4. We have 3 possibilities here. And we will look at all 3. Case number 1, using the leftmost point. I'll explain in a minute. Case number 2, using what do you think? Of course. And case number 3, wild guess, the midpoint. You can say, what's all this? In the next few minutes, Noah?
We're going to use a trapezoidal.
Yes, or Simpson rule, yes. In Calc 2, though. Of course. They're basically the same. I shouldn't say the same, but they all have a lot in common. Okay. I cannot use these 3 on the same graph. So the first one will be with the first, and then the second I'll graph again, and the third I have to graph again. So I'm coming back to my graph. I'm asked to use 4 subintervals. I will divide the interval between 0 and 2 into 4 equal subintervals. And they will all have a width of 0.5. So this will be 0.5, this will be 1, this will be 1.5, and that will be 2. I will draw vertical lines through all those, 0, 0.5, 1, 1.5, and 2. The first method will be with the leftmost point. So I have to create a rectangle that has 0.5 base and height at 0. The next one, 0.5 base and height at 0.5. Next one, 0.5 base and height at 1. And the last one, 0.5 base and height at 1.5. Well, there is no height here because the height is 0. For this one, the height is this. For this one, the height is this. And for this one, the height is this. 4 rectangles. Base times height plus base times height plus base times height plus base times height, because I'm using the leftmost point. The height is given by the leftmost point of each subinterval. Do you think that this area, we're going to calculate in a minute, do you think that this area would be of these 4 rectangles, I should say 3 by 4, will it be an overestimate or an underestimate of the actual area? Right, because there are these holes that are not filled out. Of course. Yes, Tom?
So does that mean if there's more subintervals, it will be closer to it?
Wonderful.
Well,
And what if these subintervals approach infinity? What concept is that from this course? huge one from chapter 2. The concept of limit, right?
Oh, okay, I thought you were looking for
As
like-
n approaches infinity, right? Right, we're gonna get there in a minute. Okay, so the area with left 4. This is an approximation. It's not the exact area. And we know now that it's an underestimate. This will be 0.5 times f of 0 plus 0.5 times f of 0.5 plus 0.5 times f of 1 plus 0.5 times f of 1.5. Do we agree with this estimate? Base times height, which is f of 0, plus base times height, which is f of 0.5, plus base times height, which is f of 1, plus base times height, which is f of 1.5. Agreed? Is that a yes? So I see 0.5 is a common, of course it is. And let's take it outside. F of 0 is 0. F of 0.5 is 0.25 because I have to square that. F of 1 is 1. And f of 1.5 is 2.25 because I have to plug it in x squared. X squared, 0 squared is this, 0.5 squared is this, 1 squared is this, and 1.5 squared is that. Remember, our function is x squared. So this is 0.5, and this is 3.5, is it? Correct me if I'm wrong. Okay, so 2 decimal digits. So the first area with 4 left is 1.75. This will be the lower bound of what we are going to determine. Okay, let's move on to the area with the right 4. Let's graph it one more time. 1, 2, 1, 2, 3, 4, point, point, point. So here's the graph. Point 5, 1, 1.5, and 2. But this time, this is the height. This is the height. This is the height. And this is the height. Will this area be an underestimate or an overestimate of the actual exact area? Over, because for this particular function, this will not always be the same. You can never say that the leftmost point for all graphs would be the lower bound, and the rightmost point for all graphs. Depends a lot on the function. If it's increasing, decreasing, who knows? So do not conclude. For this function for x squared, the leftmost point, the area with the leftmost point would be the lower bound, and the area with the rightmost point would be the upper bound. So can anyone dictate this area now? I'm ready. 0.5 times, I want to write something. From I equals till how many subintervals? Good. From f of xi. When I is 1, how much is xi? F of 0.5. When I is 2 for the second subinterval, how much is f of xi? F of when I is 3 for the third subinterval, what is f of xi? F of 1.5. And for number 4, what is f of xi? F of 2. I wanted to put that, insert that in there so you know what it means. So this is 0.5, indeed, f of 0.5 plus f of 1 plus f of 1.5 plus f of 2. I want to show with the graphing calculator a method of determining or calculating this in one step. Do we understand the summation notation here? Yes? Good. So let's put this in the graphing calculator. Let me show you how I would do this. I don't claim it's the best. I don't claim it's the easiest. I don't claim it's the only one. I just want to show you a method. And I can seem to be able to. What is going on? Okay, it should go. Okay, it's fine now. Okay, in y equals, clear if you have whatever. Sorry. I want stat. Sorry. So I want stat, and I want to edit. So press on stat, and you want to edit. So I want to edit list L1. And what changes here? Not the 0.5 outside, not the function, but 0.5, 1, 1.5, and 2. That's what I want. 0.5, 1, 1.5, and 2. Agreed? Let's go to list L2 and highlight the name of the list. Highlight the name of the list. Here's what I want. I want 0.5 times list L1 squared. Everything okay? Okay, in here I want the calculator to perform all the operations at once, which means I want each entry to be 0.5 times the number squared. 0.5 times this squared here. 0.5 times this squared here. 0.5 times this squared here, and so on and so forth. So I highlight a list L2, so I want 0.5. And now second and 2. I'm sorry, second and 1, of course, I'm sorry. Second and list L1. But squared, because that's the function. Otherwise, I would have put something else in there, but the function is x squared. And when I press enter, all 4 numbers will pop up. And they're all calculated. What is this again? It's 0.5 times f of 0.5 squared. 0.5 times f of 1 squared. 0.5 times f of 1.5 squared. And 0.5 times f of 2 squared. Okay, now I want the sum of L2. I go to stats, or you can determine the sum, there's another way. But I like this, and do just run one variable stats in parentheses or right here, list L2. You want to determine the sum of list L2, so you don't have to do it by hand. So click calculate, scroll down, go to calculate. Now look at these results and tell me which one will you pick from all these. And there's only one. Right. The sum is 3.75. So without calculating anything, we just put everything in the graphing calculator. We know that this is 3.75. We'll do the same for the midpoint, so we can repeat the same procedure. Okay. Let me see if I exceeded. No, that's fine. Still fine. Okay. The area with the midpoint 4. So here's the graph again. 1, 2, 1, 2, 3, 4. 1 point here, 1 point here, 1 point here. This is the graph. 4 subintervals. Here's the midpoint, here's the midpoint, here's the midpoint, and here's the midpoint. So let's show the rectangles now. This is the height, and this is the rectangle. This is the height, and this is the rectangle. This is the height, and now this is the rectangle. And this is the height. Oops, I missed it, sorry. This is the height, and now this is the rectangle. As you see, this will be the best approximation. The number will be between 1.75 and 3.75, or whatever it was, 1.7 something and 3.75. So how do I write this? Can anyone help with writing AM4? The base does not change. Yes, so this is 0.25, this is 0.75, this is 1.25, and this is 1.75. So it will be f of 0.25 plus, bless you, 0.75 plus f of 1.25 and plus f of 1.75. I don't want to do this by hand. You can if you want to. I want to go back to the same table. All I have to do is change the entries for one, and that's it. So let's go back and go back to stats and go back to edit. And you only want to edit the first one into 0.25, into 0.75, 1.25, and 1.75. Now, this may not, we may have to go back and just press again, and it will change automatically. Sorry. So what I did, I only changed these. I highlighted L2 again, and just press enter, and it will recalculate those. Did we get the same thing? And now, of course, we go to second and quit, and we'll do the same again. Stats, and we want to calculate one variable stats on L2. I just want to calculate, just give me the sum. And it has to be a number. It didn't take it, I guess. I may have to clear. It should have taken it, but I guess it didn't. So 0.5 times list L1 squared. Okay. So now I go back and I redo the stat and one variable stat and on L2, and I want to calculate yes. Okay, so as expected, it has to be a number between 1 point blah 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 and 3.75 that we got before. So that is 2.625. Hopefully at the end of the day today, we'll be able to calculate it ourselves exactly. Okay, so here's my next question. Was this a good approximation? What if I move from 4 subintervals to 8 subintervals? Will 8 subintervals give us a better approximation? What about 16? What about 32? What about 64? What am I trying to do? I'm trying to find the limit as the number of subintervals approaches. Yeah. Okay, so let's construct that. See how we do that. So n is number of subintervals. Delta x is the width of any subinterval. A comma b is the interval. Can anyone calculate delta x for us? We are dividing the interval between a comma b, a and b, into n subintervals, and I want to determine the width of one. In the previous example, we had the interval 0 to 2, and we divided in interval 0 to 2 by 4 because we wanted 4 subintervals. So we said 2 minus 0 over 4. Now I have a comma b, and I want n subintervals, and I want to determine the width of one. Of course. So b minus a divided by n is the width of each subinterval.